Well, I bet you knew it was coming. If we see our IPv4 addresses in that convenient dotted decimal notation, but computers see these addresses as binary, one of the things we should understand is decimal to binary and vice versa configurations. So let's go ahead and take a look at the IP address that we originally saw on my laptop. It was 192.168.0.18, and let's see how easy it would be to convert the 192, that decimal representation, into binary. Now, what's interesting about picking this example is that we already got a really big hint. Yeah, we recognize this as one of the original Class C addresses. And if we remember about those address classes, 192 to 223 in the first octet is Class C, and the initial bits are going to be forced to 110. Yeah, from a binary perspective. Well, let's see if that's true. First of all, one of the things I'm so excited about with this video, not only teaching you these skills, but I'm very excited because in this video, I get to teach you my handy dandy conversion chart. And notice this is a simple 2-row chart, and I build this chart anytime I'm in a certification exam that will have me doing anything with manual subnetting or conversions. Notice how this chart works. Up at the top, the first row of the 2 rows, we have 2 to the 7th power all the way down to 2 to the 0 power. It turns out these are the values for decimal in those 8-bit positions. And what are those mathematical values? Well, 2 to the 0 power, if you look on the far right, that's always the number 1. That's all we really need to memorize here. 2 to the first power is just that number itself, 2, and notice we're just doubling as we move to the left. So after a few practice sessions, you'll be able to build this handy dandy conversion chart with no problem. Again, the first row, 2 to the 7th down to 2 to the 0, and then it's 1, 2, 4, 8, 16, 32, 64, 128 as we move our way back left. This is all I ever need. I repeat, it's all I ever need in front of me as I solve questions. Now, you might be wondering, well, wait a minute, do you bring this into the test with you? No, of course not. That would be violating the testing center rules, even if you're testing at home, of course. So what I do is just quickly build it on my scratch paper or my digital whiteboard so I can reference it whenever I need to, and we'll see how handy this is going to come in throughout our subnetting exercises. All right, so that's our handy dandy conversion chart. Now let's see how we would use it in order to convert 192 to binary as we want. Now, the first thing we do is very simple. We look at that far leftmost bit position, the one that would have a value of 128, and we simply ask ourselves, can we subtract 128 from 192 and not have a negative number? And the answer is yes, we can do that. So we put a 1 in that bit position and we do our subtraction. 128 from 192 leaves us with 64. Oh my goodness, can we subtract 64 from 64? The answer is yes, we can. We won't have a negative. In fact, we are left with a 0, and that means we are done. Wow, so it's all zeros in those other bit positions. My goodness, this was so easy. We got a hint that the first 3 bits would be forced to 110, and yeah, that hint was a great one. In fact, all the rest of the bit positions are zeros. So what is 192 in binary? It's 1100 I'm sure you want to see another example. Yeah, so let's take a look at the very next octet that contains the decimal number 168. So same thing. Can we subtract 128 from 168 and not go into the negative? The answer is yes, we can. So we place a 1 in that first bit position. We do our math and we have a remainder of 40. Can we subtract 64 from 40? The answer is no, not without going into the negative. So it is a 0 in that bit position. And can we subtract 32 from 40? We sure can. And we are left with a remainder of 8. So now I can look and say, oh, okay, it's going to be 0 under the 16 value and a 1 under the 8 value, and we are done. So there you have it. 168 converted to binary is 10101000. It's so incredibly easy. And if you thought that was easy, well, hold on to your hat, because going the other direction is even easier. So what happens if we are presented with a decimal binary value, 10010011? Well, no problem. We just line up these values between underneath our conversion chart, and then we just do a whole bunch of addition. What is 128 plus 16 plus 2 plus 1? That equals 147. So 10010011 in decimal is 147. So any IP address you see now, you can practice converting that IP address into decimal, or any binary you see, you could convert back to decimal with ease. Now, as you are practicing this skill, how can you check your work? Well, that is very easy to do. Just bring up a calculator in your favorite operating system and set the calculator to either a scientific, or even better, if your calculator offers it, a programmatic view. And watch this. If I go ahead and select binary here and put in 10010011, I can see right at a glance that the decimal representation of that is the 147 we calculated. As you might guess, you could click on decimal, and let me clear this thing and put in 192, and we should see the binary we calculated of 11000000. So you can easily check your work with your calculator as you are practicing this skill. Well, thanks so much for joining me in this video. And as you know, we have just scratched the surface here in our journey of subnetting. I hope to see you in the next video.